Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 6th, 2025, so just about 5 days ago. This paper introduces a really impressive new model for virtual try-on, which is the task of realistically dressing a person in a photo with a new garment. The paper is titled, Voost, a unified and scalable diffusion transformer for bidirectional virtual try-on and try-off. And the key idea is that it learns to do both try-on and its reverse, try-off, using a single unified model. This bidirectional training helps it achieve a new state-of-the-art FID score of 5.269, where FID is a measure of image realism and lower is better. Also, the authors shared their official GitHub repository for Voost. If you head over there, you'll find the project page with more results and details. They also mentioned that a public demo for both the virtual try-on and try-off features is coming soon, so definitely keep an eye on it. Alright, so let's look at what this model can actually do. The figure here gives us a great visual summary. The top section shows the virtual try-on results, where you can see how it realistically places different garments onto people in various poses and settings. It handles everything from jackets to dresses with impressive detail. Then, the bottom section demonstrates the reverse, the virtual try-off task. Here, it takes an image of a person wearing a garment and cleanly removes it, reconstructing the original clothing item. So, to understand how the model achieves this, the authors provide a comparison of attention maps. These maps visualize what part of the flat garment image the model focuses on when generating a specific point on the person. On the left, we see a competing model, CAT VTON, shows very scattered attention. In contrast, the Voost model on the right produces sharply localized maps. This means it correctly links a point on the person, like the shoulder, directly to the corresponding spot on the original sweater, demonstrating a much stronger spatial understanding. So, to enable this bidirectional learning, the authors designed this unified pipeline. On the left, we see the input preparation. It takes the garment and person images, places them side by side, and then masks out a specific area depending on the task. For try-on, it masks the person's torso. For try-off, it masks the source garment. This is then fed into the core of the model on the right, a unified diffusion transformer. This is a powerful type of generative model that learns to create the final image by reversing a noising process. To further boost the quality, the authors use a clever inference time trick called self-correction. In the third column, you can see some initial outputs with visual artifacts, like a distorted zipper or a warped hem. But in the final column, those mistakes are gone. This works because the model essentially checks its own work. It performs a reverse try-off on its own generated image, and if the result doesn't match the original garment, it uses that error to fix the try-on. This table then details the quantitative results, comparing the model against others on two key benchmarks. On the Vuitton HD benchmark, the model is evaluated using several metrics. These include FID and KID for realism, where lower scores are better, and SSIM and LPIPS for structural consistency. The final row, showing the full Voost model, achieves the best scores across the board. The same strong performance holds true on the dress code benchmark, again outperforming all competitors, which really validates the strength of the bidirectional approach. Now, turning to the virtual try-off task, this table shows the results on the Vuitton HD benchmark. Again, using the FID and KID metrics, where lower scores indicate more realistic images, the model shows a huge improvement. The final Voost model, in the last column, scores a 10.06 on FID, which is a massive leap from the baseline try-off diff's 28.25. This result also significantly outperforms the version trained only on try-off, reinforcing that the joint training approach is key to its success. So, wrapping up, the key innovation is clearly the unified bidirectional training. By learning try-on and try-off together, the model gains a much deeper spatial understanding, which it then uses for self-correction to produce stunningly realistic images. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.